Okay, let's use those Lewis dot pictures to show the bonding for ionic compounds. Now remember, in ionic compounds, electrons are transferred. In general, these occur when we have very different electronegativities. So for the most part, things on the left are bonding with things on the right, metals with nonmetals. Let's go ahead and do a few examples. So the first example shows the bonding between sodium and chlorine to make sodium chloride. So we have a sodium atom right here with 1 valence electron and a chlorine atom right here with 7 valence electrons. Let's go ahead and show these bonding. So I'm going to start off by drawing my sodium individually. Sodium has a symbol Na. It has 1 valence electron. It is not happy. It does not have its full octet. So we either need to dump that 1 or gain 7 more. Being a metal, sodium's barely holding on to those electrons. It holds them rather weakly. So sodium is going to get together with chlorine, a nonmetal that has a great big electronegativity. It pulls electrons towards it. Chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Now, since sodium holds its electron loosely and chlorine has a great attraction for electrons, what happens is those electrons get transferred. This electron from sodium is lost and goes on to chlorine. Chlorine will then have its full octet. And then, as an answer, what I am going to have is a sodium ion, a sodium that was neutral. If it lost, it's negative. If you lose negativity, you become positive. And chlorine will now have an excess of electrons. It now has 1, 2, 3, 4, 5, 6, 7, 8 electrons around it. If you gain a negative, you become a -1 charge. And all of these chlorines, these electrons belong to chlorine. I will draw brackets around that to say these are just chlorines. They're not shared with sodium. Now, the attraction between a +1 and a -1, well, an attraction between opposite charges is an ionic compound. So there's your first example. Let's try another one. So how about showing the Lewis dot picture for calcium fluoride? Calcium, being a metal, holds onto its electrons loosely, and fluorine, being a nonmetal, really pulls the electrons. In fact, fluorine is the most electronegative atom of all. Let's show the bonding process. I'm going to go ahead and start off with my calcium. Calcium in the second row has 2 valence electrons, 1, 2. Now, I have 2 fluorine atoms right here. I have a fluorine, I'm going to draw on one side, that has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Now, if these get near each other, fluorine is going to rip that electron right off of calcium. And if it rips that electron off of calcium, well, then fluorine will have its octet. Great. This fluorine will be more stable right now. It's got the octet. However, calcium still has 1 more electron to lose, and I have 1 more fluorine atom. So I'm going to write the other fluorine on the other side with its 1, 2, 3, 4, 5, 6, 7 valence electrons. This fluorine is going to rip the other electron off of calcium, and that fluorine will also gain its octet. So in the end, what you're going to have is a calcium atom that has lost not 1 negative, but lost 2 negatives. You lose 1 negative, you become positive. You lose 2 negatives, you become +2. Then on this side, I've got a fluorine with 1, 2, 3, 4, 5, 6, 7, 8 electrons. They all belong to fluorine. It becomes a -1. You grab a negative, you become negative. This fluorine on the other side has a 1, 2, 3, 4, 5, 6, 7, 8 valence electrons because it grabbed the extra 1 from calcium. It becomes a -1. A calcium 2+ is bonded to two -1 fluorine atoms, and you've created your calcium fluoride. All right, one more example. Last example is bonding for magnesium oxide. Again, we have a metal, magnesium, with a non-metal, oxygen. That is most likely going to be ionic, metal, non-metal, great big difference in electronegativities. So let's show the bonding process. I have one magnesium atom. This magnesium atom has 2 valence electrons, 1, 2. Now I've got one oxygen atom right here that has 6 valence electrons, 1, 2, 3, 4, 5, 6. Oxygen needs 2 more to complete its octet. Well, magnesium's barely holding on to its 2. So oxygen steals them and rips them off of magnesium. So one of the electrons goes to complete this side of oxygen. The other electron goes and completes my bottom side of oxygen. Now at this point, my answer is going to look like the following. Magnesium has lost not 1 negative to become positive, but it lost 2 negatives to become positive 2. Oxygen has gained 1 negative and another negative. It becomes -2, and it has a complete octet around it. I'm going to show that with brackets saying these all belong to oxygen and a 2-. A +2 bounces a 2-, and we have magnesium oxide. So remember, if you're doing Lewis dot pictures for ionic compounds, show the transfer of electrons, making those complete octets. I hope that helps. Take care.